Hello, this is Mike from FairRepair, and today we have a new device on my bench. Compared to what I have usually on my bench, this is actually a really rare and antique device. This is a DELL XPS M1710, and if I remember correct, this is actually one of these devices which suffered from the so-called NVIDIA bump gate issue. So this has the GPUs, the NVIDIA GPUs inside, which suffers from insufficient edge bonding, I mean underfill, between the die of the GPU and the substrate, between the square and the green stuff. Yeah, and these GPUs have died a lot, and it was in the news, and NVIDIA got a lot of bad feedback about this. Of course, absolutely right. What a mess. And this was the time from where the idea originated to bake a GPU in the oven. You know, the oven in the kitchen. This is the time where the people had the idea to bake the GPU in the oven, and actually it worked. For this generation of GPUs it worked, but it worked maybe for 1 day or 1 week or maybe a few months, and finally it will die. This GPU will die for sure. So the good old oven method cannot be called a fix. No way. No, and this also applies to everything else with what we deal these days. Reflowing or baking or whatever can never be called a fix. It's nonsense, basically. Basically it is nonsense. The only situation where it might be advised to reflow, or better to reball a big BGA like a GPU or a CPU, is when the device was actually dropped or suffered from other physical damage, like a board was bent in some way. These are the only situations where it might be worth a try to reflow or reball a BGA. Because still many people are thinking when we have a shorted CPU or a shorted GPU, a reflow will revive it. This is absolute. Every time I hear something like that, it is really frustrating actually. And annoying. Yeah, but yeah, this is what I wanted to say about this device. But this device is something special because it works till some extent. This device works. Let me power up the benchtop power supply. So now it is on, it draws 10 amps, and when I press the power button it draws actually 1.5 amps. The display gets darker, and that's it. That's it. Nothing happens on the screen. But the caps lock is actually responding, which tells me, as a somewhat experienced technician, the board does actually the power on self-test successfully. So the board is working, and most of the logics are working and present. However, we have no picture. So my good friend, this laptop is from a former colleague of me, where I employed earlier, a few years ago, and I have this device from my former colleague. He bought it in this condition, as far as I know, in this condition, and he already tried to replace the screen, and obviously it did not work. So it is not a screen issue, and the board is working very good to some extent. So which tells me we have, and also the behavior is not conform, is not as usual. Normally you deal with missing backlight in these cases, but actually it appears like the backlight comes up, so the screen goes dark, but which probably means the backlight is coming into the game. But yeah, we have no picture. So it is like the world is upside down here. We have not the issue with a missing backlight, where the logo, the Dell logo and everything else is still visible, but only very dark, very dim. So no, this time we have no picture at all, even not the dim picture. So it is like the world is upside down, and we are not dealing with a problem with the main power rail here, but more likely with an issue with the 3.3, or maybe even one of the enables, which are supposed to enable the panel, located on the motherboard, of course, on the main board, of course. Yeah, and this is our job now. It does show picture external. Let me try to show you. It has a good old VGA connector. I hope you can see that. This is the actual display of our device. I power it down now, and now the display disappears. Alright? So hopefully it was visible. Yeah, and this is with what we deal here. So there's no way around to open this device and to check what is going on with the panel here, what is going on around the panel here. Yeah, so let's power down everything. Also the battery needs to be removed, so we don't do any mess here. Yeah, here, VGA cable. Not bad, huh? Yeah, this is really an old device. Okay, maybe we can flip over now carefully. So how can we remove the battery? Oh, this is everything. Not bad. The good old times, I can tell you, the good old times. But I have the feeling this assembly will be a mess. Really a mess. So let's remove the panel now. Whoop. Okay. Oh, this is the hair. Okay. So now remove the panel. One and two. Yeah, this is good. Okay. Really interesting fault. I have no idea whether I can fix it, but we will try, of course, no? As always. So let's see what we can do here. I don't know, do we need to remove it? Let's try with the big screws first. Display connector looks good. Here we have some, let's zoom in a bit. Yeah, here we have some dirt. Okay. This is probably nothing. Good. Connector looks clean so far. Maybe we can do something for the connector. Let's see. Yeah, good. Nothing. Okay. Who knows? Who knows what it does? Who knows? Something happens here. Something happens here. But yeah, this is not enough. Actually, we can't spot most of the signals because there's probably a lot on the other side of the board. But here could be a 3.3 array. This could be. Where is my multimeter? Yeah, careful. Ground. In the USB port we have ground, no? Here we have almost nothing. 3.3, okay. And 0. Do you have spotted that? Once again. And fire. 0.1, 3.3 and disappearing. Interesting, no? What could it be? Resistance to ground. Here's ground. 1.8 kilo ohms. Sounds about right. Sounds about right. Yeah. There's no way around. We have to disassemble it. No. Without screen nothing happens on this track. So yeah. It tries. This is from my understanding, this is clearly the 3 volts supply for the screen, and it is disappearing for some reason. I don't understand right now, but yeah, and this is probably our issue here. So now the question is, does it disappear because there is a problem on this power rail? Or does it disappear because there is a problem with the enable, which controls the switch which led the 3.3 through something like a transistor or MOSFET to the connector? This is the question where is our job to answer. Yeah, and yeah, right now I don't even know the board number, so we have to research everything. But first we will continue disassembling the device, so we have better access to everything. Okay, let's find out which one is the power button. Before moving further. So not much to do. We need the ground reference, ohms mode. So start with the first pin and then we'll simply press the power button, but this is already ground. Pin 2. It is not free. Free. Huh? Weird. Maybe. Here. 4. It is 4. So pin 4 is a power button. This is good to know because we have to remove the palm rest now. And now we can short it with a tweezer. To ground, yeah? To ground. Pin 4 to ground. Good. So, and this is now an interesting plot twist because it seems this is a MXM card, maybe, and the display connector is actually located directly on this MXM card. Oh my god. Wow. Wow, wow, wow. Okay, let's remove this heatsink here. Yes, we can. This is the old GPU, huh? And here we have something which could be responsible. Thermal paste looks actually really good, huh? Let's zoom a bit in. So what should we do now? So this is one of these GPUs, but it is a better revision with the good underfill. This is probably the reason why it is still alive. NVIDIA G07900, so probably GTX 7900 generation, huh? Series, huh? Good. And we have no second LCD connector. Really? So why is it not working? Any ideas? Let's check the MOSFET here, the switch. This is the switch which drives the 3 volts, the 3 VS line, the power rail, to the LCD, to 3 volts LCD. It has to be enabled from the gate pin, of course. This is the N-channel MOSFET, so we will expect, taking in account that we need 3 volts at source, probably something like 9 volts or 10 volts at gate, so the MOSFET can open. Resistance we can check without power. So 2.4 between source and drain. 34 between source and gate. and 32 between source and drain. This looks okay so far. So what is the issue here? Let me connect the display again. Come a bit closer. Yeah. So let's plug the display again. Like that. Power is plugged. Multimeter, voltage mode. And now we'll do some meaningful measurements. Starting with the 3 volts LCD. Power. We need the display connected for this measurement, because without the display present we won't get any voltage here. Where is the detection before? We need the display connected in any case to get 3 volts on this track. Otherwise this would be misleading. So it is turning on and we get 3.2. We have picture, what? .3, 10 volts, 3.3. So what is the issue here? What is the issue? Huh? What is the issue? Now from battery. Can we do it? Should work, no? Yeah. Now from battery. Because something is fishy, yeah? Still working. I can't believe. Something with the display. So we have an issue with the cable here. Likely. Let's check again. Let us connect the heatsink first. So one after another. Once again. So turning on. No. It does not like my power adapter. No, it is not the cable. It is not the cable. How weird is this issue, please? How weird is it? It's pretty weird. Pretty weird. Okay. I mean, I've cleaned the connector, but it did not help, so I have no idea what is happening here. Let's check the power rails again. So this is the 3VS and it has only 240 ohms, which is suspicious to some degree, but can be with such old devices, can be actually okay. Yeah, the only way we can figure this issue is probably to observe, and to observe. Yeah. Very odd. Very, very odd. So power button is connected again. Oh, now it's already not working anymore. See? It's not working anymore. So, and now we have, where is ground? This is ground. So, and now we have our and now we have our 3 volts here, but here we don't have voltage anymore, and we don't have voltage at gate. Alright? This is gate of the MOSFET. So what? Off. So I've done nothing else than to connect the palm rest. All right? No, it's not working. So, but when I grab my tweezer and short the pins, then it still won't work. Okay. Good. So here we have a logic issue, and now we have to find out what it is. So this is probably the mouse pad, which we will remove now. And it is working. See that? I've just removed the mouse pad and now it is working. How can this be? Now plug again. Power. And it's not working anymore. Unplug the mouse pad. And works again. Not bad, huh? Not bad. So we have a problem with our mouse pad here, with our trackpad. Touchpad? How is it called in English? So what is the sorcery then? What is the sorcery? What is wrong with our pad? No, it does not go to the mouse pad, it goes to the LEDs, to the buttons here in front. Let's see whether the cable causes this problem, or whether the PCB here causes this problem. Okay, we have actually this panel here and the mouse pad here connected to this cable. Alright, so we'll rule out one after another. We'll start with the media panel here. No picture, okay. Now we'll plug the panel back and disconnect the trackpad. Yes, now we get picture again. Okay, so the issue originates from the touchpad. Definitely. So the connector is called JTP 1, 3, 5, 7, 9, 11. 11 is lit close. Connects to this cable. This is weird. And ground. Alright, so we have figured all 6 pins at the connector here. And now we'll check compared to ground what we get here. Let's see. So this is a 5 volts run, 1 kilo ohms clock, 6 kilo ohms data, 6 kilo ohms. This is lit close. Oh, look here. 300 ohms only. And ground. This is LED underscore TPB and ground. So we have actually an issue with the lit switch. Who would have thought? An issue with the lit switch. And I think it is this one here. Q1. It is not Q1? Maybe not. But where is it then? Okay. Let's search for the lit switch. Good. Where are you, Mr. Lit Switch? No. So where are you? Resistors? What's this one here? Is this the lit switch? Must be the lit switch, no? And how can I fix it now? I have no idea how I can fix it now. So what do we know right now? We know that the old Hall sensor is bad. It causes the internal display randomly not turning on. I've already played around with it, but I see no way how we can make it back work. So we have basically 3 options now. 3 options. The first option is to replace the Hall sensor. with the exact part. Unfortunately, although we have schematics of this device, I have schematics, but the touchpad with the buttons is not part of the schematics. And yeah, this device is like 20 years old, so I have no idea what part it is. So I can't source it. And I don't have a donor board with this lid switch too. So the first option we can't do. Second option would be to simply remove it. This would work. The display would show picture. But yeah, the basic function of the hall sensor will be lost. So if I close the display without turning off the laptop, the display would not turn off, but it would stay on, permanent. So yeah, I'm not fan of this option. Yeah, then we have a third option. A third option would be to replace the lid switch, the hall sensor, with something else, with another hall sensor. And the only part I have available is this one here. This one. Yeah? This is a small SOT23 hall sensor, contrary to this 2-pin hall sensor here. It is also much smaller. So yeah, we have to perform some tricks to implement it. Also, we have a third pin here. Here we have 2 pins. We have the lid switch line and we have ground. Here we have the lid switch line, ground, and we need a permanent 3 volts always supply too. So what do we need now to transplant this hall sensor? We need the wire, of course. Wire. Present. Good. Then we need a present 3 volts always supply, preferably near the connector. So how can we check? Power. And with the help of the schematics, I've found a suitable point here. Here's the connector, yeah? And here we have a small capacitor with 3.3 always supply present. So here we will solder our wire. Then we'll route it all over the way here. Yeah? Along with the original wire. Here, and finally to the touchpad. We'll solder the hall sensor here and come with the third wire here for the 3 volts always supply. Somehow. And yes, this is a real Frankenstein solution. I've never done it before, but why not trying? Why not trying? I think this could be interesting, no? So let's try. Alright. So we have removed the old lid switch already. Let's solder one wire here. Good. And yeah. So now we soldered a wire here. So now we'll cut the wire in half, like that. Yeah, good. we try to solder the ground pin. Oh, we need more flux. Yeah, this looks already good. Good. This looks like a stable connection. So our ground plane is a bit messed up here. Let's try to remove the solder here. Good. Better. Yeah. Good. So this is somewhat stable in place in the middle. So, good. I had to add another thinner wire to the touchpad because the bigger one did not stay in place, but yeah, basically no change. No change in the design. So yeah, wire is soldered. The lid switch, the Hall sensor, is supposed to drop the voltage when we come with the magnet. Ooh. So let's see what happens when I come with the magnet. Yeah, it drops. See that? Pay attention to the top left here. Pay attention to the voltage. This is the lid switch line, alright? So when I come with the magnet, voltage drops. Back to 3.3. Voltage drops. 3.3. Voltage drops. 3.3. Alright? Wonderful. Good. So the Hall sensor is working. There is no question. The reason why it doesn't turn off the display is another reason. So yeah. I would say we are ready to assemble this device finally, and yeah, leave it like that. So everything is cleaned up here. Now we'll cover everything with solder mask. So here we go, Dell Touchpad revision 2. Yeah, this is one of the most interesting things I've built in the last months. Interesting. One last check, I would say. Yeah, now you can see better. So now the magnet and the display turns off. Magnet back, display turns on. Magnet, display turns off. So we have achieved a full functional Hall sensor, which is great, really great. So let's unplug power, because now we want to finally assemble the device. Cool, huh? So let's see whether it still shows picture to start with. And it does. This is a good news. So now the question is a bit dark. Now you can see something. It's a bit dark. It tries to boot from battery. So I try to go into the BIOS. Okay. It works. It works definitely. I just have no way to show it to you. But it works. See? Once again. Yeah. From black to blue. Great. Great, 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 great. One sec, let me higher the brightness. Yes. Okay, now brightness is way higher. Close. And not bad, huh? Close. And from black to picture. Wonderful, wonderful. Yeah. Yeah, this was a really interesting repair. I hope it was interesting for you too. I can't thank you often enough for your great support. Thank you for watching. Leave a comment, a like, or even a subscription for my YouTube channel if you like my videos. If you're interested in the tools I use, then take a look into the video description. See you next time. Bye.